Okay, picking up where we left off yesterday, relative frequency of a class is the portion of the percentage of the data that falls in that class. To find the relative frequency of a class, you just divide the frequency, f, by the sample size, n. So relative frequency is f over n. Remember, the sum of the relative frequencies should be 1. Now, because you round, in most cases, it's going to come close to 1 the majority of the time, but not going to be exactly 1. But it should get real close to it. Don't forget that the following sign is used for summation. Most of you have seen that before. The cumulative frequency of a class is the sum of the frequencies of the class and all the previous classes. Remember, like cumulative GPA is your GPA over all 4 years. So you're just adding it all up. I mean, it's not exactly the same, but cumulative just means over the course of all of them. Cumulative frequency of the last class is equal to the sample size n. So your cumulative frequency at the very last class should be all of the different samples that you took. Okay. So now we're taking what we had, which was a regular frequency distribution, and now we're going to expand it out further. So first we're going to find the classes, the frequency, the midpoint, or class mark, relative frequency, and cumulative frequency now. So we still have to start with the classes. So it says we have 30 portable GPSs, construct a frequency distribution that has 7 classes. I believe this is the same example as before with the GPSs. So we can really use the same classes and frequencies. Tried to make the examples easy enough so that we could pull that off. Great. All right. That's what I was afraid of. For whatever reason, it makes me copy the entire table. Okay. So we go to the next page. We'll put those classes in. We're just copying the classes from before. All right, I'm just going to copy these in. Okay, so I finally got all this information copied over from the last table we had. Now we have to find the midpoint or the class mark. So you do 104 plus 65 and then divide that by 2. That gives you 84.5. So we're at 84.5 and then you go up 40. So 124.5, up 40 more, 164.5. And make sure this makes sense. 164.5, yeah, it's about in the middle of those two. You don't want to end up with like a number that's way off because you made a simple mistake. Then 204.5 and 244.5 and 284.5 and lastly 324.5. So now when we do relative frequency, it's going to be the frequency divided by the total number. So in this case, it's going to be 6 divided by 30. So when we do 6 divided by 30, we get 0.2. The next frequency is 9, so you do 9 divided by 30, which is 0.3. Then 6 divided by 30, which is 0.2. Then our next one's going to be 4 divided by 30, which is 0.133, repeating. 2 divided by 30, 0.06666, repeating. 1 divided by 30, 0.033, repeating. And then 2 divided by 30 again, which is 0.066. Now if we take these relative frequencies and add them up, they should add up to 1. So go ahead and add these up, because that's the only way that you will know for sure that you did the relative frequencies right, other than the fact that you know how to divide. We add those all together, we get 0.998, which is pretty close to 1. Only reason we got 0.998 is because we rounded these off. Those ones. Our cumulative frequency, 6. Then you add the next class on, which is 9. So 6 plus 9 is 15. 6 plus 15, 21. 21 plus 4, 25. And 27. 28, and 30. So your cumulative frequency should be the number of your sample size, n, which is 30. So you did good. Okay, let's do the same thing with the 50 most powerful women. Go ahead and copy the information down from your other table and then try this on your own. Pause the video and then you can play it and I'll have all that stuff done. Okay, so this is all the information we had from the table from last time. Now we just need to add the relative frequency in. So you're going to do 2 divided by 50, because there's a total of 50 data points, I believe. Yeah. So you're going to do 2 divided by 50, gives you 0.04. Then 5 divided by 50 gives you 0.1. And 12 divided by 50, 0.24. 18 divided by 50, 0.36. 11 divided by 50, 0.22. 1 divided by 50 is 0.02. So these last two would be 0.02. Remember that some of this should be close to 1. So we add those all together. And that gives you 0.1, or a total of 1. Now cumulative frequency, it's 2 plus 5 is 7. Then 12 plus 7 is 19. 18 plus 19 is 37. Then 48, 49, and 50. So pretty easy overall. Just remembering how to do it. Okay, graphs of frequency distributions. Frequency histogram is a bar graph that represents the frequency distribution of a data set. A histogram has the following properties. So the horizontal scale is quantitative and measures the data entries. Vertical scale measures the frequency of the classes, and consecutive bars must touch. So in a frequency histogram, you always want to make the bars of the bar graph touch. No spaces in between your bars. So because they have to touch, then the bars have to begin and end at class boundaries instead of class limits. Class boundaries are the numbers that separate the classes without forming gaps in between them. So like if you look back at our table here, our class limits was 26 to 34. Well, that does not match up with 35. There's a gap in between them. So we have to go with class boundaries, which is the difference between these two, or the distance in between them. So this is going to move up to like 34.5. This is going to move down to 34.5. So for data that's integer, simply subtract 0.5 from each lower class and add 0.5 to each upper class in order to set your class boundaries. So going back to that one we just did, let's zoom in on this a little bit. All right, a lot of it. Our boundaries would then be 64.5 going up to 104.5, and 104.5 to 144.5, 144.5 to 184.5, 184.5 to 224.5, 224.5 to 264.5, 264.5 to 304.5, and 304.5 up to 344.5. Now we have to do those frequencies again. So now we just copy our frequencies over from the other table. 6, 9, 6, 4, 2, 1, 2. Now we do our data points. So as we look at this, we're going to do price in dollars across the bottom. Frequency, which is the number of GPS navigators. And then I'm going to label these with the midpoints that we had from the last table. So 84.5, 124.5, 164.5, 204.5, 244.5, 284.5, 324.5. Now, some people might wonder what this is. This symbol means that there's a jump in the graph. It's perfectly acceptable to have this symbol in a horizontal axis, but you should never put that symbol going up this side or on the vertical axis. Because what it does is it skews your data. And we're going to do a lesson on, just the beginning of a lesson on how to lie with statistics and how to skew your data. Okay, so since it's frequency distribution, we're now just going to go along these classes and make our distribution. So the first one has a frequency of 6. And so this is going to be ugly for me, but I'm going to go up to 6. Oh gosh. You should come halfway in between. Because remember, these are your midpoints or your class marks. And so you should come halfway in between those two. Next one is 9. That one wasn't terrible. Then 6 again. And 4. And 2. And 1. And then 2 again. So the nice thing is this creates a pretty good way of looking at the data. Makes it easy to see what is going on in the actual frequency distribution. And I'm doing the same thing, but I'm going to label it with class boundaries. So your graph's going to look exactly the same, but we're going to have the actual class boundaries. And so this is 64.5 up to 104.5, then 144.5, 184.5, 224.5, 264.5, 304.5, and lastly 344.5. Then again, you're just going to do your frequency. But here, because you're doing your class boundaries, your graph actually touches the marks. 6, then 9, 6 again, 4, 2, 1, and 2. So when you look at this data, it looks exactly the same as the one above it, except for the fact that these actually touch the marks. Some cases it's going to ask you to find the class or use a class mark for it. Other times it's going to ask you to use your class boundaries. Okay, I want you to try this with the women's ages one. And I will do the same thing and pause the video and we can check back in. Okay, this is what your table should look like. Now it doesn't say whether we use class marks or class boundaries for this. So you can do whichever one you want. I'm going to go ahead and use my class boundaries. Okay, so those are all filled out. Now we can just do our frequencies. Oops. We're going to set a bad example. Since I used my class boundaries, maybe my first one starts with here. And it's there. And there. And up to 12. Some ugly bar graphs. And up to 18. And 11. One. And 1. So not too hard, just time consuming to rewrite all this stuff on the table and then redraw your tables again. Okay, a frequency polygon is a line graph that emphasizes the continuous change in frequencies. And so when we're doing a frequency polygon, we're taking those same frequencies and just doing a different type of graph. So it starts at the 64.5, and my frequency is 6, and so that's where I start. Then 9, then 6, and 4, and 2, and then 1, and 2. And so that's your frequency polygon. Pretty easy. Relative frequency histogram. All we're doing for this is doing a relative frequency. So we're just taking our relative frequency that we had from that table that we drew. So it'll have the same shape and same horizontal scale as the corresponding frequency histogram, but the vertical scale just measures the relative frequencies. So when we looked at the relative frequency, we had 0.2, 0.3, 0.2, 0.13, 0.066, 0.03, and 0.066. And so we just list those out, make the corresponding bar graph the exact way, and you're done with it. Cumulative frequency histogram, or it's called an ogive, not no give, for the record, is a line graph that displays the cumulative frequency of each class at its upper class boundary. Upper boundaries are marked on the horizontal axis, so we're going to start with the upper class boundary. And the cumulative frequencies are marked on, upper class boundaries are marked on the horizontal axis, and cumulative frequencies are marked on vertical axis. Here's how you construct an ogive. You start by constructing a frequency distribution that includes cumulative frequencies as one of the columns. Specify the horizontal and vertical scales. Horizontal scale consists of upper class boundaries. Vertical scale has to measure the cumulative frequencies. Plot points that represent the upper class boundaries and their corresponding cumulative frequencies. And connect the points in order from left to right with line segments. The graph should start at the lower boundary of the first class and should end at the upper boundary of the last class. So if we start at the lower boundary, and for 104.5, we go up to here, and then all the way up. 144.5, 184.5, 244, 264, 304, and 345. Or 344.5, sorry. And so your ogive is going to start at the bottom, and then it works its way up. You're just following the cumulative frequencies column that we have in that table. So you started from the bottom, now you're here. It'll never get old for me. Alright, and that's the end of the section. So it's a lot of work, but it's pretty simple. Okay, tomorrow you're going to start with doing the odd questions. I understand there were some concerns about the last assignment you had to do that came from a book. It was real hard to read, so I broke it down and made it a little easier for you to read it. But you're going to do the odd questions in class tomorrow. Whatever you don't finish, you do for homework, and then even questions the next day, and then we go over it all. All right. Thank you for your attention.